Hey, this is Mr. James. In this video, we'll be talking about slope, parallel, and perpendicular lines. Before we can get to the parallel and perpendicular lines, though, we'll need to review slope and slope-intercept form. I'd like you to go ahead and try questions 1 through 5 on your own, and graph the following 3 graphs at the middle of this page. If you're having trouble with any of these, please go back and refer to the previous video. The answers will be coming up in 3, 2, make sure you try these on your own, because all of this are important prerequisite skills. Here are the answers. Here are some of my answers for the first section. Pause the video if you need to write any of these down or check your work. And here are my 3 graphs. Again, pause the video if you need to check your work. Now, make sure you're graphing these correctly. If you need to correct something on your paper, just erase it and try again. Some things to watch out for is the negative slopes, right? Make sure that negative 3 over 2, you're going down 3 over 2. Make sure when you graph this slope of 3 right here, it's 3 over 1. So you're going up 3 and over 1. And also make sure you're getting these y equals 2 and x equals negative 1 lines correct. Remember, y equals 2 is that horizontal line and x equals negative 1 is that vertical line. And it might help you, like I did, to graph these in 2 different colors. So if you didn't do that originally, you can always go back and change it, or perhaps even highlight or go over the lines you've already drawn. Could help you now and in the future. So let's start talking about our main event here, the parallel and perpendicular slopes. The interesting thing about the 3 graphs we just created were that every pair of lines was either parallel or perpendicular to each other. Let's start by looking at the second graph right here, where we have the line y equals 3x minus 1 and the line y equals 3x minus 4. They appear to be parallel. Why is that? Well, that can be explained by looking at the slopes. Both of the slopes in those lines are 3. They're equal to each other. So it seems like when we have slopes that are equal, we create parallel lines. Now that kind of makes sense because the slope tells you how steep the line is, the rise and the run. And if 2 lines have the same steepness, then they're going to carry on with the same rate of increase or decrease and never intersect each other. So let's make a note of that down here. The slopes of parallel lines are always equal to each other. So I've put a quick example here. Y equals negative 7/8 x plus 4 and y equals negative 7/8 x plus 6. It doesn't really matter what the x-intercept is. That'll just control how close or how far apart our parallel lines are. But to make them parallel, they've got to have the same slope, equal slopes. Well, those were parallel lines, but what about perpendicular lines? Lines that intersect at a 90-degree angle. Well, if we look at the first graph here, it seems like we've got 2 lines that are perpendicular. They intersect at a 90-degree angle, or right angle there. Well, let's look at the actual lines, the equations of the lines. The blue one is y equals negative 3/2 x minus 1, and the red one is 2/3 x. I guess we could call it 2/3 x plus 0, because the y-intercept here is 0. But what we're really interested in is the slopes. The blue line has a slope of negative 3 over 2, and the red line has a slope of positive 2/3. You may see a little pattern here. One slope is positive and one slope is negative, which means these 2 slopes have opposite signs, positive and negative. In addition, the fractions here are flipped. One is 3 over 2, the other is 2 over 3. We call that being reciprocal. So it seems like 2 perpendicular lines have opposite signs and reciprocal slopes. Let's put a couple notes down here. The slopes of perpendicular lines are opposite reciprocals to each other. Opposite means we're going to change the positive and negative sign, and reciprocal means we're going to flip the fraction over, the numerator and the denominator. So here's an example. If I had y equals 3x plus 4, the slope of the first line was 3. So the slope of 3. Now I'm going to change the positive and negative sign, so my new slope for a perpendicular line would be negative 3. But also, remember, 3 is the same as 3 over 1. So the reciprocal slope, flipping the fraction over, would be negative 1/3. And that's what I have here. Y equals negative 1/3 x minus 7. Just like parallel lines, the y-intercept doesn't matter at all. Could be anything. But as long as the slopes are opposite reciprocals, flip the fraction, change the sign, and you'll get perpendicular 90-degree slopes. One last thing I wanted to mention is on this third graph here. We have a horizontal line, y equals 2, and a vertical line, x equals negative 1. Now, remembering from the review, we know that the slope of this horizontal line is 0, okay, and that the slope of the vertical line is undefined. It turns out that a zero slope and an undefined slope are also perpendicular to each other. Now, this actually makes sense with the opposite reciprocal note from before, because if you think about a slope of 0 is the same as 0 over any number, let's say 1. And an undefined slope we get from dividing by 0, a slope like any number divided by 0. And if you look at these two slopes, the fractions are flipped over. The numerator and the denominators are reciprocals of each other, right? So even though we say a zero slope and an undefined slope are perpendicular, really we're still saying that opposite reciprocal slopes are perpendicular. Let's flip to the backside to determine whether lines are parallel or perpendicular without a graph. Are these sets of lines parallel, perpendicular, or neither? Pause the video here and look at each pair of lines and determine whether those lines are parallel, perpendicular, or neither, and think about why they might be parallel or perpendicular. Pause the video now. The answers for 1 through 4 will be up in 3, 2, 1. The first line we have here is y equals 2x plus 3, and the second line is y equals 2x minus 5. Notice the slopes of both lines are 2, and they are equal. Equal slopes means the lines will be parallel. Next, let's take a look at 2. In 2, we've got y equals 3x plus 1 and y equals 1/3 x plus 5. Now you might think those two lines are perpendicular to each other. After all, the slope of the first line is 3, or 3 over 1, and the slope of the second line is 1/3, or 1 over 3. Now those two slopes are reciprocals of each other. The fractions have been flipped over, where the numerator and the denominator have been switched. But remember, for perpendicular slopes, they need to be opposite reciprocals. Opposite means that one is negative and one is positive. Unfortunately, they're both positive, so they're not going to be perpendicular. If, for example, this one was negative, then yes, they would be perpendicular. But in fact, they're not, and so this is a neither. When we look at something like 3, we've got x equals 2 and y equals 5. Remember, x equals 2 is going to be a vertical line with a slope that is undefined, and y equals 3 is going to be a horizontal line with a slope that is 0. Now, a horizontal and vertical line, those are definitely going to be perpendicular to each other. Now, 4 is a little more interesting because in 4 we actually can't tell whether these are parallel or perpendicular right away because they're in standard form, not in slope-intercept form. So what we'll have to do is rearrange both equations and solve for y to figure out what the slope is going to be. Let's go ahead and do that. Since I have to work with both equations, I've rewritten the 4x plus 2y equals 10 over here just so I have some space to work with. So I'll start with the 2x plus y equals 3. To solve for y, I'll have to subtract 2x from both sides. And I'm left with y equals negative 2x plus 3. Okay, what about this one? Well, I'll have to subtract 4x from both sides. And that leaves me with 2y equals negative 4x plus 10. And then to isolate the y, I'll have to divide both sides by 2. And let's see, that leaves me with y equals negative 4 divided by 2 is negative 2x, and 10 divided by 2 is 5, so negative 2x plus 5. And look at this. The slopes of both those lines are negative 2, right? Negative 2x plus 3 and negative 2x plus 5. Since the slopes are equal, the lines will be parallel. Now that you've seen 1 through 4, go ahead and try looking at 5, 6, 7, and 8. Again, the answers will be up in 3, 2, 1. Next, let's take a look at 5. We have y equals 2x plus 3 and y equals negative 1/2 x minus 5. Notice the slopes, 2 and negative 1/2. Those are going to be opposite reciprocal slopes. If you can't tell why, take a look at this. The first slope, 2, is really positive 2 over 1. The second slope, again, is negative 1 over 2. They are opposites because one is positive and one is negative. The sign has been changed, positive, negative. Also, they're reciprocals because the fraction has been flipped over. The numerator and the denominator have been changed. So, because they're opposite reciprocals, these lines will be perpendicular to each other, and they'll form a 90-degree angle. Now in 6, we've got y equals 5x plus 1 and y equals negative 5x plus 1. Now you might be tempted to say these are parallel because these ones are the same, and doesn't that mean they're parallel? But wait, that's not the slope. That's the y-intercept. And the y-intercept doesn't matter at all when we're looking at parallel and perpendicular lines. It's all about the slope, this 5 and this -5. Now, they won't be parallel because 5 and -5 are not equal slopes. So, are they perpendicular? Well, they're definitely opposite slopes because one is positive and one is negative. But remember, to be perpendicular, they've got to be opposite reciprocal slopes. So, this could be 5, but unless this had kind of that flipped over fraction, maybe something like 1 over 5, then it would be perpendicular. But if you just have 5 and -5, those aren't reciprocals. There's no flip of the fraction there. So since they're not opposite reciprocals, they're not perpendicular. And since they're not equal, they're not parallel. This is a case of neither. Let's push on to 7. In 7, you've got x equals 2 and x equals 5. Thinking back to how we answered number 3, remember that x equals 2 is going to be that vertical line with an undefined slope. And x equals 5 will also be a vertical line with an undefined slope. If you think about it, two vertical lines, well, those will certainly be parallel. I mean, they look parallel because they're both going straight up and down, but also they both have the same slope. And same slope means that those two lines are parallel. In our last example here of 8, we've got y plus 3 equals 2/3, parentheses x minus 1, and y minus 3 equals -3 over 2, parentheses x plus 1. Now when you look at these things, you might be a little confused because these aren't in standard form and they're not in slope-intercept either. They're in point-slope form, which we're not going to use very often, but it's useful to know. Point-slope form is y minus y1 equals slope times x minus x1. Now remember, the only thing that matters for parallel and perpendicular lines is the slope. And so all we need to do is focus on this value here, 2 over 3, and this value here, -3 over 2. Well, they're not the same slope, so they're not going to be parallel, but wait, are they opposites? Yes, one's positive and one is negative. Are they reciprocals? Yeah, 2/3, flip that fraction over, you get 3 over 2. So these two slopes are opposite reciprocals. Remember, nothing else matters here, only the slope when you're talking about parallel and perpendicular. And since the slopes are opposite reciprocals, that means they'll be perpendicular to each other. Now that we've had a little bit of practice, let's move on to the next section. We can also find the equation of a line that passes through a following point if we already know another line that's parallel or perpendicular to it. For example, in number 1, we want a line that passes through -4, 2 and is parallel to y equals 2x plus 3. Now you may remember from previous videos that whenever we write an equation, we need to know two things. We need to know the slope and we need to know the y-intercept. And in fact, you already know the slope just by looking at the question. Remember that parallel lines have the same slope. So we'll take the same exact slope that this line has, and that will be the slope of our new line. So the slope of our new line is 2. But we don't know the y-intercept. So we need to find the y-intercept using the method we've learned in previous videos. Start with the equation, y equals 2x. But we don't know the y-intercept, so we'll put plus b. Using the coordinates at this point, -4 for x and 2 for y, we'll substitute in, bringing down the slope and the plus b, and then we'll solve. 2 times -4 is -8, sorry. Bring down the 2 and the plus b, and now we'll add 8 to both sides to isolate that b, get it by itself, and 2 minus 8 is -6 for b. So it turns out my y-intercept is -6, and my final answer will be y equals 2x minus 6. Again, we got the slope because we know that the two lines are parallel and they'll have the same slope, 2, and we got the -6 by using the process we learned before to find the y-intercept. Let's start 2 together and then I'll have you finish on your own. If we wanted to create a line that goes through -4, 2, but is perpendicular to y equals 2x plus 3, well, let's think. Again, we're going to need a slope and a y-intercept. Now, for perpendicular lines, we won't use the same slope as this line. We'll use the opposite reciprocal slope. So remember, 2 can be 2 over 1. And so the opposite slope, this is positive, so we'll have to have our perpendicular slope be negative. And the reciprocal, flipping that fraction over, that'll be 1 over 2, or 1/2. So my slope will be -1/2 x. Now, let's find the y-intercept. and I'm going to let you do this on your own. Pause the video, use what we've learned before and our new slope of negative 1/2 to find your new y-intercept. The answers will be up in 3, 2, 1. So I got 0 equals b, so my y-intercept is 0, and so my final answer, my line is y equals negative 1/2 x plus 0, or since we really don't even have to label 0 on there, we could leave it as y equals negative 1/2 x. That ends this video on parallel and perpendicular slopes. Hope you got everything. Good luck, and I'll see you next class with the video check.